Designers can achieve big reductions in the embodied carbon in buildings. Amy Hattan, Thornton Tomasetti's Corporate Responsibility Officer, is talking with in-house experts about how they're reducing the effect of buildings on climate change. Here's how Embodied Carbon is a production of Thornton Tomasetti.
Hello, welcome to episode 8 of Here's How Embodied Carbon. This series explores how engineers and designers can reduce embodied carbon, or the emissions associated with building materials, and minimize the negative impacts of buildings and other structures on climate change. I'm Amy Hattan, Corporate Responsibility Officer for Thornton Tomasetti, a multidisciplinary engineering and consulting firm. We've been focused on embodied carbon for over a decade and are channeling all of our capabilities to tackle climate change. I'm talking with colleagues about how they're achieving reductions in greenhouse gas emissions on their projects. Today, I'm talking with my colleague, Patrick Kenny, a structural engineer at Thornton Tomasetti who co-leads the materials working group of our embodied carbon community of practice. Patrick has a love-hate relationship with concrete, as do many structural engineers with an interest in reducing embodied carbon. This is Patrick's second time on this podcast. He was my guest on the first episode of season 1. Today, he'll tell us about one of the concrete industry's biggest initiatives for reducing their carbon footprint, Portland-Limestone cement. Hi, Patrick.
Hi, Amy. Thanks for inviting me back onto this series to take a look at Portland-Limestone cement.
So what is Portland-Limestone cement?
Let's start with the more familiar cement that everyone has been using for decades, Portland cement. Portland cement is covered by a standard specification called ASTM C150. This cement is made by heating a mixture of limestone and clay to very high temperatures, over 2,600 degrees Fahrenheit, to produce clinker, which looks like rough rocks. The clinker is then ground into very fine powder, and that is Portland cement. Now, all that heat has a large carbon emission. The ASTM C150 standard allows a small amount of raw limestone, which is made with no processing or cooking, to be added to the clinker. But no more than 5% of the final product can be this raw limestone. In 2012, Type 1L, or Portland Limestone Cement, or PLC, was added to ASTM C595, which is the blended cement specification. In this specification, there has to be at least 5% limestone content, and it can go up to 15%.
Why is increasing that limestone percentage so important?
Again, the raw limestone requires none of the emissions associated with heating and producing clinker. By reducing the amount of Portland cement and replacing it with limestone, we can get a 5 to 10% reduction in embodied carbon. Here is an intriguing fact. If all the cement used in the United States in 2019 had been converted to PLC, it would have reduced CO2 emissions by 8.1 million metric tons. That's equivalent to taking 1.75 million cars off the road for an entire year, according to the US EPA.
Wow. What are the consequences of using PLC? Are there downsides?
PLC can replace traditional Portland cement with a 1-to-1 ratio, so there's no volume difference. And it's compatible with all the other supplementary cementitious materials that we would normally use in any concrete mix, such as fly ash or slag. When PLC is used without supplementary material, its compressive strength is equal to or better than normal cement mixtures over time. Freeze-thaw resistance, scaling resistance, chloride ion penetration, and alkaline silica reactivity are also comparable between PLC and traditional Portland cement. For post-tension slabs, where we need high early strength, the two mixes are very similar, just as good, if not better. So performance-wise, there is really no difference. On a recent project where we used PLC and some of the other supplementary cementitious materials for a high-strength shear wall, we calculated the embodied carbon of our design and compared it to what it would have been for using only Portland cement. There was a 37% reduction.
37%? So using PLC seems like a no-brainer, is it?
Yes, it absolutely is. The good news is that because it's such a straightforward improvement with no significant downside, the cement industry is in the process of switching most production in the US to PLC. Many major markets have already made the switch. You can reach out to any of your local cement or ready-mix concrete suppliers to see if your region has already switched or has a planned timeline for switching. In the near future, we'll all get this embodied carbon reduction on all of our projects without even trying.
Wonderful. Is there anything that professionals can do to speed this along?
As engineers and architects, we just need to make sure that our specifications allow for ASTM C595, which is the blended cement specification. So we're ready when our suppliers change over to PLC.
Thanks, Patrick. I love a short podcast that offers a quick and logical solution. Hooray for Portland-Limestone cement! If you'd like to hear more about other ways to reduce the embodied carbon in concrete, please check out episode 1 of season 1. And folks, there's more. Follow Thornton Tomasetti for more episodes of Here's How Embodied Carbon.